Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, good night. Berapa dah? Pukul 11. Okay, so this is series number 3. So, Bismillahirrahmanirrahim. Okay, this is series number 3. So, I want to continue part B. We will analyze Sidesway frame. Sidesway frame means table number 2. Okay, this is Sidesway frame. Sidesway frame. So I have actually drawn this diagram. This is Sidesway frame. This is Sidesway frame. So this frame is subjected only okay. There is only R prime in the diagram. There is only R prime in the diagram. So this R prime is in right direction. Okay, is in right direction. So the frame will move to right direction, because based on original diagram, we know that frame is tend to sway to right direction. So that is why in Sidesway frame we have to analyze the frame which is proportional. Okay, which is proportional to the diagram, to another diagram. Okay, which will be based on the principle of superposition. Actually, if we refer back to the principle of superposition, kan kita ada negative R plus R. Okay, negative R plus R. So asalnya dia ada negative R plus R. Negative R, the one that we analyze in the first part in table number 1, and to neutral back this negative R, so we have to put plus R. So this is plus R actually, but we cannot analyze frame which is subjected to R, okay, in right direction. We can only analyze frame which is subjected to R prime, because this frame we can assume the FEM. We cannot assume FEM for frame subjected to R, because R is the value that we want. Due to R there will be delta. Okay, the delta is the real delta, so we cannot assume the moment, the fixed end moment due to delta, because delta is unknown and we cannot assume the delta. Okay, so what we can do is we will analyze another frame. Okay, not the frame that we get directly from principle of superposition, because from principle of superposition we get negative R plus R. Okay, negative R plus R. So the Sidesway frame, the real Sidesway frame is the frame subjected to R in right direction. Okay, but we analyze another frame which is proportional to the previous one. Okay, but this is subjected to R prime. Subjected to R prime. Okay, kalau nak recall balik, dia konsep dia macam ni kan. Kita ada frame. Okay, macam ni lah lebih kurang the frame tu. This is original. So so we apply principle of superposition, we get this. So this is R. Okay, plus with this. This is R. Okay, so this is delta. But this delta, we do not know the value, and we cannot assume the value. Okay, then we also cannot assume FEM. Okay, and this R, okay, this R actually we get from this, because that is actually in table number 1, the R value that we calculate will be used here. Okay, will be used here. So here we have negative R plus R. Negative R plus R. Okay, but what we analyze under step number 2, table number 2, is not this. We don't analyze this directly. I have mentioned previous time, a few times, we do not analyze okay, this frame directly. So what we can analyze is another frame which is proportional to this. Okay, so the proportional frame that we analyze, okay, under step number 2, table number 2, is the same type of frame subjected to R prime. So due to R prime, there will be delta prime, okay, and due to delta prime, there will be M prime. So this is the end moment that we are going to determine in table number 2. Okay, so the one that we have analyzed is M naught. Okay, and we have another M here. This is M. Due to R, due to delta, there will be M. Due to R, okay, we have to compare these two table. These two frame. We have to compare these two frame. This frame as well as, okay, the two frame that I have circle. Okay, dua-dua ni yang kita kena compare. So table 2 refers to which diagram? Table 2 refers to this one. This is table number 2. Okay, so R value yang kita calculate tadi tu, kita bukan nak pakai dekat sini. So kita ada sini. Okay, I need to label. So this is A, okay, B, C and D. Okay, R value yang tadi kita calculate dekat first table, gunanya dekat sini. Because dekat dua-dua diagram ni, yang saya bulat ni kan, dua-dua ni kita ada kat sini R, sini kita ada R, kita ada M. Okay, dekat second diagram we will have R prime dengan M prime. So dua-dua ni kita akan buat interpolation because yang kita nak cari is actually M ni yang kita nak, M. Okay, R ni kita nak, tapi kita dah dapat from first table, kita dah dapat dari sini because it is just opposite direction. Okay, yang kat bawah ni table number 2, kita dapat R, kita pun dapat M prime. Okay, so when we compare this using interpolation, when we compare these two, we have R and M, and then we have R prime and M prime. So we just need to rearrange this back. So okay, bukan this, kita nak terbalik M. Okay, M sini, M dengan R, M dengan R. Okay, sini M prime dengan R prime. M prime dengan R prime. Ni punya relationship. Okay, this relationship will bring us, okay, M which is equal to, kita kumpul R ni sekali, okay, kali dengan M prime. So yang ni yang actually kita nak buat. Okay, yang ni M equal to R over R prime kali dengan M prime. So R dengan R prime ni we call it as correction factor. Yang ni nama dia correction, okay, correction factor. Okay, saya ulang lagi before saya betul-betul fokus on solution table number 2. Okay, kenapa kita buat tu due to delta prime. Okay, because we need to understand the concept before we can start doing anything. Okay, so we have frame. Okay, we have frame. So this is original frame subjected to loading P and W. So due to this, because of unsymmetry loading, kena ingat definition symmetry, definition non-sidesway frame. Definition dia kalau dia betul-betul simetri. Betul-betul simetri means dia mesti simetri due to loading, dia mesti simetri due to geometry. Barulah frame tu only has loading, no sidesway. Okay, but by looking at this diagram, so this is not symmetry. This is not symmetry sebab ada P tu dia tak simetri. Okay, bila ada P dia tak simetri, so dia akan ada sidesway. Sidesway is delta. So dalam case ni, dalam soalan ni, dalam frame ni, dia ada dua benda, loading and delta. Okay, so load yang FEM tadi tu ada dua-dua kan. So kita ada kat sini W plus delta. Kenapa saya hanya tulis W? Okay, kat sini sebab W ni akan produce FEM. P tak, sebab P ni at join. Okay, P at join. So dia ada combination. Dua-dua ni kita kena pisah. Okay, dua-dua ni kita kena pisahkan. So macam mana nak pisahkan dia? Untuk pisahkan dia, kita number one, kita kena remove delta. Macam mana nak remove delta? Kita letak support kat sini. Bila letak support, dia akan ada R. Okay, bila kita letak R tu, dia akan jadi properly restrained. So properly restrained is another definition of non-sidesway frame, non-sway frame, properly restrained. So kena remain lah, kena remain dekat sini. Okay, external loading kena remain. Okay, P ni pun remain. Okay, so yang ni bila ada R ni means that it is properly restrained. Okay, this is properly restrained. Properly restrained. Okay, bila kita letak negative R kat situ, negative R dia jadi properly restrained. So now frame ni kita kena completekan dengan another one that will comply the principle of superposition. Okay, the principle of superposition. So we have to put this. Okay, so yang ni akan jadi macam ni, because we need to remove, we need to have W and delta in separate diagram. Okay, in separate diagram. So what we have is yang ni W, ni ada W, yang ni tak ada W. Okay, and then we have 0 plus delta. So dapat balik lah yang original ni, dapat balik yang ni. Okay, so delta kat mana? Delta ni kat mana? Datang daripada R tu. Okay, datang daripada R, because kat sini ada negative R, so plus dengan R. So we know that positive R means right direction, negative R means left direction. So dekat sini, to make this frame as sidesway frame, so this will subjected to R in right direction. So that is the meaning. Okay, so bila kita nak calculate nanti end moment for the diagram, the main one, okay, the main diagram, so we have to have two table. Okay, two table. Okay, but the idea is we want to calculate end moment that we label as M final. Okay, I put down. Okay, M final ni, okay, which is equal to, okay, let's say because table 1 is referring to this is table number 1. From table number 1 we get M naught. So this is M naught from table 1, and we have to plus M for this diagram. For this diagram, okay, because based on equation, kita nampak lah based on equation, this is the equation. So due to R, dia akan ada dekat sini delta. So sini akan jadi delta. So dua-dua delta ni equal kalau straight column. Okay, ni delta. So tengok simbol dia, R delta, delta produce M. R delta, delta produce M. So kat sini we label as M lah. So dekat sini M. M. But diagram ni, diagram yang hujung ni, yang 1, 2, 3 ni, okay, this diagram, okay, this diagram, okay, this one, this is the real one. Okay, the real delta, the real moment, so we cannot assume. We cannot assume. So that is why the moment that we calculate in table number 2 is not this, based on this. Okay, we calculate n moment indirectly. We calculate moment indirectly. Okay, because this will produce M. This will produce M due to delta, due to R. Okay, so what is this M? Okay, what is this M? This M is actually equal to R divided by R prime kali dengan M prime. How we get this? Using interpolation. How we get this? Using interpolation. So we have to have another frame which is proportional. Which is proportional. That is why dalam buku teks ada. Okay, so we have two. Okay, we have two. This, okay, this is R, this is R prime. This is R prime. So kalau dekat first diagram ni, due to R ada delta. Sini. Okay, sini delta dia. So due to R prime akan ada delta prime. Okay, and due to delta akan ada M. And due to delta prime akan ada M prime. Because we cannot assume this. We cannot assume. We cannot assume. Okay, cannot assume this. So what we assume, okay, actually, okay, what we assume actually based on the diagram subjected to R prime. So due to R prime there will be delta prime, and due to delta prime there will be M prime. And moment in table number 2 is M prime. So from this we can have relationship between M and R, and then between M prime and R prime. Of course, R value for this frame we get from the first table. Because it is negative R plus R. Negative R plus R. Okay, negative R plus R. Sekejap suara okey tak? Is M prime. So from this we can... Tak apalah ya, lagging sikit tapi masih clear kan my voice. Kita tak tahulah sebab apa nama, streaming software ni memang macam tu. Okay, dia kena laptop dia kena power sikit lah. So lagging ni tak apalah ya. Okay, we continue. So okay, compare these two lah. We compare these two. Bila kita compare these two, what we get is, okay, kita nak relationship between M dengan R. Delta dengan delta prime, okay, kita tak buat relationship between delta. We only produce relationship between M dengan R, and M prime dengan R prime. Okay, yang tu. So it is M dengan R, dengan sini M prime dengan R prime. So kita nak make relationship. Okay, so we use interpolation lah. So what we have is M, because what we want is M is unknown. So M, so we bring R to the other side. So we group R dengan R prime together. So R over R prime, we call it as correction factor, kali dengan M prime. So why we have correction factor? Because FEM that we use to calculate M prime is based on assumption. That is why ada correction factor. That means that we can actually assume whatever value. Okay, but we have to maintain or remain the behavior, the right behavior of FEM. Okay, so that is why ada correction factor, because FEM yang kita pakai dalam table tu memang assumption. Okay, not the real one. Assumption. That is why ada correction factor. So R divided by R prime is correction factor kali dengan M prime. Okay, then we will get M. So this M we substitute into the final formula. So we get M final, which is equal to M naught plus R divided by R prime kali dengan M prime. So this will be the final equation. Okay, so now we want to focus to table number 2, frame number 2. So frame number 2, the one that we have analyzed, okay, today is this. Due to R prime, okay, due to R prime, so here is A, B, C, D. So sini A, sini B, sini C, sini D. Okay, so most important thing, one incline, when there is one incline column in frame, so kita dah tak dapat lagi delta yang sama macam yang frame yang straight column tadi. Dia akan jadi delta 1, delta 2, delta 3. So each element dalam frame ni akan produce different delta. So kita akan dapat sini satu delta. Okay, sekejap. 90 degree. And then sini pun 90 degree. Okay, so we need to join this. Okay, join this as the new position of beam. So this is new position of beam. Okay, then this is the triangular for AB. Okay, and then this is triangular for CD. Okay, so kita nak gabungkan 3 delta prime. Delta 1 prime, delta 2 prime, delta 3 prime. Okay, delta 1 prime perpendicular to member AB is yang ni. Okay, perpendicular dengan member CD is this. Okay, so kita gabung satu yang ni, satu yang ni, satu lagi completekan triangular. Okay, so yang ni delta 1 prime, horizontal delta 2, delta 3 prime, vertical delta 2 prime. Okay, so where is this triangular in the diagram? Okay, where is this triangular in the diagram? So we have to identify where is the position of this triangular, because we need to calculate the angle, the value of the angle. Okay, because we want to make relationship between delta 1 and delta 2, delta 1 and delta 3. So we have to identify where is this. Okay, where is this is located. So it is actually located at dekat sini ya. Dia dekat sini. Okay, sebab yang sengit ni memang untuk member 1. Okay, yang horizontal ni sini. Okay, sini jarak dia, sebab ni lukis tak sama kan, tak sama scale. So jarak sini dengan jarak sini should be same. Okay, dua-dua tu same. So horizontal dan for horizontal, for vertical member the data must be horizontal. So this is actually the triangular. So for beam, which is horizontal element, the delta is vertical. So this is the triangular. So the most important thing is we need to be able to identify the angle kat dalam ni. Kat dalam ni ada dia punya angle. So angle ni, theta ni, we have to identify the value. The delta. So dapat dari mana? Dapat daripada dapat daripada trigonometri ni. Dia macam ni. Dia kat sini 3 meter, sini 7 meter. Okey, dekat sini 3 meter dengan 7 meter ni apa? Sini A dengan B. Okey, sini A dengan B. So we want to have ada okey, jangan letak sini lagi. Letak sini dulu. So we want to have this theta lah sini. Okey, kita nak cari theta for AB because AB itu incline, AB ni incline. Cari dulu nilai ni. Okey, cari dulu nilai ni. Kita pakai tangent. Tangent theta sama dengan 7 divide by 3. So arc tangent kita dapat theta sama dengan 66.8. Okey, 66.8 tu kat mana? 66.8 ni di mana 66.8 ni dia macam ni, kolom ni kan. Okey, kolom ni A, ni B. So ni this is 66.8. 66.8 means that segitiga tu dia dekat sini. Ni 90 degree, so ni segitiga tu. Sini 90 degree. So mana dia 66.8? Dia dekat sini 66.8. 66.8. So yang ni tadi kita akan dapat this as 23.2. 90 minus 66.8. Okay, this is the angle. So angle ni is important. This is just okay, yang ni semua PO1. This is all the mathematical, the basic knowledge of mathematics yang mana we need to apply in moment distribution method. Nak buat apa kita buat step ni? For determine the ratio between delta 1, delta 2 and delta 3. Because from this we will calculate FEM. Okay, we will use the FEM. Because by referring to the formula FEM tu, okay, so yang ni kan. So step dia step number 1 kita buat macam ni. Assume FEM for AB equal to FEM for BA. Okay, it is sidesway to the right direction. It rotates clockwise, so FEM must be negative. So this is negative 100 kilonewton. And this negative 100 ni, to get this we need to apply formula. Formula dia 6 EI delta 1 prime, because this is for AB, divide by length dia tadi 7.62 ke. Okay, length dia tadi berapa dia punya length? Mana dah? Okay, the length dia is, yes, 7.62. 7.62. Okay, sini 7.62 L squared. Okay, this is equal to 100. Okay, negative 100. Okay, so dalam this formula, so apa yang ada dalam formula ni? We have E, we have I. EI ni is actually flexural rigidity. And then we have delta, and then we have L. Okay, so EI, delta and L. Empat ni is actually called as parameter. Where whenever the all these parameter ratio dia equal, so equal lah juga nilai assumption tu. Okay, so dalam ni ada apa? Ada E, ada I, ada delta, ada L. Okay, so empat ni we call it as parameter. means that FEM, okay, FEM will be influenced by this EI, delta and L. Okay, 4 ni as the parameters. So kalau ratio setiap satu ni sama, okay, yang ni ratio dia semua sama ratio. Okay, for each element lah, element AB, element BC, element CD, each element kalau semua ratio dia sama, okay, so kita akan dapat same. Kalau kita assume 100, so we will get 100 jugalah. Okay, but in this case setiap member ada different EI, ada different delta, different juga L. So all these different L, different delta and different EI will produce different FEM because the ratio is not 1-to-1. Okay, the ratio is not 1-to-1, so that is why we have to calculate FEM for member BC and FEM for member CD, which is related to negative 100. Okay, so okay, actually I have explained how the FEM for BC and CD was calculated, okay, by referring to the example in the textbook. Macam mana example dalam textbook tu buat. But I have also prepared one video where I have shown to you the simple method how to identify or calculate FEM for member BC and member CD after we assume FEM for AB. Means that FEM for BC, FEM for CD are related to FEM AB. Okay, so macam mana kita nak buat yang tu? Okay, I have actually tabulate under one table. Okay, so okay, we have 3 members. We have member AB, we have member BC, we have member CD. Okay, assumption that we made. We have assumed that FEM, okay, for AB is negative 100 because of the behavior. Negative is for the behavior, means that CD also we will get positive. BC we will get CD also we will get negative because of the behavior. CD we will get positive. Kita boleh check yang ni. Okay, sebab AB ni dia macam ni. Lepas tu dia rotate ke mana? Ke sini delta dia kan. Then dia rotate clockwise. Bila rotate clockwise, FEM dia jadi negatif. Okay, so yang ni dia punya chord rotation lah. Yang ni dia punya chord rotation. If you want to compare. Okay, lepas tu BC kan. BC ni beam. Beam ni original dia horizontal. After sidesway dia jadi incline macam ni. Okay, so this is the beam after sidesway. Okay, the beam after sidesway. So the angle is negative. Angle kat sini negatif. That is why FEM dia mesti dapat positif because dia opposite. Okay, and then kolom CD dia macam ni. Kolom CD dia macam ni. Okay, kolom CD angle dia macam ni. Okay, sama juga sebelah sini. Okay, so angle dia positif. When angle is positive, FEM is negative. FEM is negative. Okay, FEM is negative. Okay, yang ni comparison tadi kita compare FEM kan. So value ni yang kita nak carilah. Value ni kita nak. Okay, we will actually calculate these two value. So value tu yang kita nak. Because value tu yang kita nak masuk dalam table. Okay, now we apply formula. Okay, we apply formula. So formula, the formula to calculate FEM. Okay, yang ni kita apply. Kejap. Okay, formula dulu. Okay, formula for AB is 6EI. 6EI delta 1. Delta 1 prime over L is 7.62. Okay. So, formula number, ni formula lah. This is formula. Okay, formula yang number 2 kan. Formula ni adalah 6 times 2 EI delta 2 prime over yang ni 6. And then for CD 6 EI delta 3 prime over 9 square. So kena solve yang ni lah. Kena solvekan yang ni. So what we get? What we get? Kita kena tukar semua jadi sebutan delta 1 baru kita boleh calculate the ratio. Okay? Calculate the ratio. So delta 2 dalam sebutan delta 1, delta 3 dalam sebutan delta 1, kita pakai balik triangular tadi tu. Triangular tadi ni. Okay, sini. Yang ni 23.2. I have actually calculated. Okay. So, yang ini delta 1 prime, ni delta 2 prime, ni delta 3 prime. So, buat relationship as usual. So, yang ni kita dapat cos. Okay, cos sin dulu. Sin 23.2 equal to delta 2 prime over delta 1 prime. So from this we get delta 2 prime equal to sin 23.2. Sin 23.2. Okay, sin 23.2 we get 0.394. It is 0.394 delta 1 prime. Okay, and then satu lagi is cos. Cos 23.2 we get delta 3 prime over delta 1 prime. So we get delta 3 prime equal to cos. Ini cos lah, 23.2. 23.2 we get 0.919 delta 1 prime. So this value, okay, we substitute 394. So what we get is, kita substitute into this. So what we get is, kita terus calculate lah, So we get 6 divide by, ni semua square. Okay, 6 divide by 7.62 square. So we get, in terms of, what we want is in terms of EI delta prime 1 prime. So this is what we want, the ratio. So this is 0.103. Okay, and then we calculate 6 times 2, 12. Okay, times tadi tu 0.394. 0.394. Okay, divide by 6 kali 6, 36. This is 0.131. Okay, then ratio for the last one is 6 times 0.919 divide by 9 square. So we get here 0.068. Okay, inilah. So from this kita akan calculate balik FEM for BC and CD using ratio lah. So from this value we will calculate the value of, okay, the value of this X and Y. Okay, and this based on this. So Kita interpolate lah, interpolate. So what we get is okay, interpolate. How to interpolate? Interpolate kalau you cannot see macam mana nak buat directly, so you buat macam ni. You buat macam ni ya. Macam ni ya. Okay, it is 0.103 yang ni equivalent to 100. So if I have 0.131, what should be the value? Okay, interpolate. So darab silang lah. Okay, darab silang. So 0.131 divide by 0.103 times 100. So we get 0.131 divided by 0.103 times 100. So we get FEM. FEM is 127. 127.18. 127. So tulis kat bawah lah ya. Okay, so we get X, which is actually FEM, BC, FEM, CB equal to positive 127.18 kilonewton meter. Okay, macam tu. Okay, so we do interpolation. The next interpolation is 0.068 divide by 0.103 times 100. So yang ni we get 66.02. 66.02. So Y we get Y is equal to FEM, CD equal to FEM, DC equal to negative. Okay, negative 66.02 kilonewton. Okay, meter. Moment. Okay, so the value in the table yang tadi itulah, yang ni lah yang kita dah calculate tadi tu. Okay, 127.18. Ini ada 127.18, and then 66.02. Okay, so this is actually the value that we need to transfer into Excel. Okay, the same Excel that we use in table number 1. Okay, table number 1. This is the table number 2. Okay. Ini ya. Okay, so FEM AB BA, FEM AB BA is negative 100. Negative 100. Okay. And then berapa tadi yang kedua? 127. 127.18. 127.18, it is positive 127.18. Okay, 127.18. Okay, and last value is 66.02. Negative ya. 66.02. We must put the right sign representing the right behavior. 66.02. Okay, macam ni. Okay, then dapatlah dia punya moment kat bawah ni. Okay, this is M prime. This is M prime. So this is M prime. So I copy this table. Allah. Sekali lagi. Okay, so Control C. So I paste here. Kat sini. So all these values are actually M prime. So we have 6 values, sama juga macam table 1 ada 6 values, start from AB until DC. So dah dapat yang ni, actually I think I don't need to repeat step 3A, step 3B and step 3C because it is exactly the same. Step 3B, the moment distribution in the table, that's why I just put the FEM, then directly I get the M prime because I have set the formula inside, and then use this M prime value. We have to determine the R prime value, and then using R prime value will be determined using shear equation, and then we have to determine the AX and DX as well as AY in this case, because it is member AB is vertical, this is inclined, so we have to have AX and AY, okay, so that we can get R prime value. So refer back to the video number 1 yang mana saya dah tunjuk tadi macam mana nak calculate R. So guna step yang sama, ulang balik the same step, hanya tukar nilai M, so that you akan dapat nilai R prime. Okay, so yang ni je yang saya nak highlight untuk this example, dan lepas ni saya akan tengoklah malam ni ke kalau tak pagi ke kan, saya akan buat satu lagi video untuk cover another type of frame which is close with the one that you will get in assignment question tomorrow. Okay, yang ni saya ajar sebab saya nak fahamkan konsep about delta tu mesti perpendicular, macam mana dengan R. Okay, nak fahamkan konsep. Tapi yang saya akan bagi esok is actually lebih kurang macam ni. Lupalah, lebih kurang macam ni lah. Lebih kurang macam ni. Tak berapa ingat sangat. Okay, lebih kurang macam ni. Masih ada satu incline, tapi saya tukar kolom tu daripada ke bawah letak ke atas. Okay, masih lagi we need to apply the same principle, the same concept. Delta dia mesti perpendicular, kena cari R guna shear equation, R and R prime guna shear equation. So yang ni yang kita akan tengok dalam next video. Okay, something like this lah, okay. So till we meet again in the next video, insyaAllah. Assalamualaikum warahmatullahi wabarakatuh.